Hello everybody, welcome to Chapter 1, Section 1. This is a short lecture in a series of all the lectures that I'm going to do to try and get you a little bit of information that you are going to be responsible for when you come into class. The idea is that you are the one in charge of listening to lectures, reading the section prior to coming into class and doing the work for that section that day. Well, what's up in Chapter 1, Section 1? The title of this section gets into sets, elements, the roster method, and real numbers. And we really start off with the most basic of the types of sets that we deal with in all of mathematics, and that is the set of natural numbers, whole numbers, and integers, and dealing with some basic definitions. All algebra starts with definitions, so the first one we're going to ask is, well, what is the difference between saying natural numbers and whole numbers? Actually, this is a really easy one right here, because when we talk about what the set of natural numbers are, our natural numbers, I'll write this on the board here, natural numbers are numbers starting with 1. Just like you would count with your hand, 1, 2, 3, 4, 5, and so on. The whole set of natural numbers includes the set of numbers starting with 1, whereas the set of whole numbers adds an additional concept of the number 0. Then we start counting with 1, 2, 3, 4, and so on down the line. Each of these represents our set of numbers. So the difference, of course, between these two sets is that the whole numbers contains 0, meaning nothing. It's funny that we should have a whole number devoted to nothing, but it's a very important concept because our mathematical system would not be what it was without that 0. So the second question is, well, what do we mean by integers? In the set of natural numbers and whole numbers, you can think of it this way. We can take natural numbers, any two natural numbers, and add them together, and we're going to get another natural number. If you take 2 plus 3, you're going to get 5. If you take 200 plus 3, you're going to get 203. In any case, those are always natural numbers. And the same thing can be said for whole numbers. If we add 0 to any number, we get that number itself. But what about subtraction? Will that work? Well, in some cases it does. If I take 5 and I subtract 4, I get 1. That is still a natural number. But what if I try to take 4 and I subtract 5 the other way around? Well, not so much. We don't get a natural number or a whole number, so the set of integers was invented to allow us to bring in that additional concept. So our integers are going to include both the positive and the negative values of each of those whole numbers. So going in order from smallest to largest, the set of integers is the set of all positive and negative whole numbers. And 0. And so subtraction, of course, works. Here we could take 4, subtract 5, and we're going to get negative 1 as a result. Well, that didn't come out too well. Let me try that again. I guess when I have to really pick up my pen to make sure I don't make those kind of marks here, equals negative 1. There we go. Okay, so our natural numbers, of course, can all be mapped out on a number line. If we put it on a number line, of course, we can think of that whole idea of addition, subtraction, and so on as being mapped out on this number line, but we think of numbers at 0 being the origin and going to the right 1, 2, 3, 4, 5, and so on, just representing the places of those numbers. And of course, any numbers in between, which we'll talk about later. Positive numbers are go to the right, negative numbers to the left. And so any number that is to the left of another number is thought of as being less than the other number. So in this case, we could really say that negative 3 is less than positive 1 because negative 3 is to the left of positive 1. Any number to the left is less than any number to the right. Now, one of the ways that we categorize numbers is that we try to group them together. And so we think of the set of natural numbers or the set of whole numbers as a set in and of itself. But when we want to write a set of things that go together, we'll group them together. And one way to do it is called a roster method. A roster method is a way of putting the numbers together in such a way that we have a set that goes together. And typically, we will put them in curly brackets that look kind of like these ones right here. You can see an example of those below. And we say, well, what are the positive integers that are less than 5? Well, positive integers, when we think about our integers, of course, our set of all integers is the set, as we indicated before, that starts with all of our negative and positive whole number values, such as these. And we want to find all of those that are positive but less than 3. Well, we can mark out 0 since that's not going to be a positive number. 0 is sort of a unique case in and of itself. But our positive numbers could include 1, 2, 3, and 4. We're not going to include 5 because that's not less than itself. So we would stop right there and we would close our brackets and indicate that this is our set of positive integers less than 5. There we go. Okay. Now, on this set right here, we might ask, well, all right, here's a given roster of numbers. It looks like we've got a set of integers. Looks like they are odd numbers, positive and negative, between negative 5 and positive 5, including those. So we ask, well, which of these elements are less than or equal to negative 1? Well, in this case, when we say less than or equal to, we're asking you which numbers, including negative 1, are going to be in this set. Well, clearly, negative 1 will be a number that's in this set. Could it be 0? No. Too large. But on the other hand, negative 3 is most certainly in this set, as is negative 5, since it is to the left of negative 1. And those three elements make up our set less than or equal to. More to come in the next video.